In this work, we are dealing with wastewater treatment plants, which are industries devoted to reducing the pollutant components of residual urban waters. These are characterized by performing highly complex and non-linear biological and biochemical processes and by adopting control strategies to support them. Besides, these kinds of industries have been modeled by the benchmark Simulation Model No.1. It consists of 5 reactor tanks where the biological and biochemical processes are modeled. It also implements a full control strategy which is based on the implementation of proportional integral controllers. As it is observed, this kind of controller is able to track the dissolved oxygen variations by means of modifying the oxygen transfer coefficients. In this world, the default PI controller is going to be changed by internal Model 1. However, the processes we are going to control are not fully invertible. For that reason, we are going to model them using artificial neural networks. To implement this new controller, data from different wastewater treatment plants concentrations are required to train artificial neural networks. In this case, a whole year influence showing different waters is considered. Besides, the oxygen transfer coefficient corresponds to the IMC actuation variable, while the dissolved oxygen is the control one. Then, the two artificial neural networks are implemented in Keras and TensorFlow. Each network has 3 hidden layers and 50 hidden neurons per layer. Finally, the training process of the artificial neural networks is finished once the algorithm reaches either a local minimum of the cost function or the maximum number of epochs. Once both artificial neural networks are trained, they are implemented in the benchmark Simulation Model No.1, which is in charge of modeling the inverse and direct models of the 5 reactor tank. Finally, the behavior of the IMC controller based on artificial neural networks is tested with different weathers. In the case of rainy and stormy weathers, we can see that the IMC controller is able to follow the peaks of influence that are produced. As a conclusion, the proposed IMC controller based on artificial neural networks is able to track the dissolved oxygen when different weathers are considered, or in other words, when different influence profiles are adopted.